Okay, dear students, today's we start today's session on the big data analytics. And last time we have discussed the data warehouse and various terminology related with the uh, big data analytics environment. Okay, and today we'll start to discuss the CAP theorem that I have told earlier that in the previous class, and that the CAP theorem is very important to understand the big data environment. Okay, and before this class, we have discussed about the distributed system and the parallel versus distributed system also. Okay, so let's start with the CAP theorem, that is also called CAP theorem. Okay, CAP theorem is basically uh, you can say here there are the three terminology from here you can see that that one is consistency. C represent consistency, and A represent availability, and P represent partition tolerance. Okay, so it is impossible to provide all the three. By basically you just have to think in this these three parameters: consistency, availability, and partition tolerance. Definitely we know that it is impossible to provide all the three quantities qualities to any of the user. At best you can have two of the or at the best you can have two of the following three. One must be sacrificed. Okay, so let me start with the definition of first one, that is consistency. Okay, so consistency implies that every read, actually there are when we discuss about any database and data warehouse, there are the basically two operations are performed: read and write, basic operations here are performed. So the definition of consistency means that implies consistency implies that every real fetches the last write basically. Okay, means every read fetch means basically every read fetches the last write that is available, and availability implies read and writes are always succeed. In other words, each non-failing node return response in a reasonable amount of time. That is called availability. Okay, and last we have partition tolerance. Okay, partition tolerance. Uh, Here we have implies that the system will continue to function tolerance, that is related to continue system will continue to function when the network partition occur, because it works on the network basically. In summary, we can say that basically in the CAP theorem, we can say one can at most decide to go with two of the three out of these three basically. And okay, so we have to decide where to choose the consistency over the availability, in vice versa. Okay, right. So choose availability or consistency when your business requirement allows some flexibility basically. Okay, and when the data in the system synchronize manner basically. Second point, choose consistency over availability. Basically, when your business requirement demands atomic read and writes. Okay, so at the right hand side of the figure, means in the right hand side we have, okay, the figure. You can see example of database, possible database. These combination that we can see in example of the database basically. So possible three combination are there. The first one is availability and partition tolerance. Suppose let us start this particular combination. Okay, so A is available, availability is available, operational all the time. So each client from the from, so each client can always read and right? That is called availability. Okay. And P stand partition tolerance, means the system works well despite physical network partitions. Okay. So, and the combination of A and P here we have, okay, just a minute. If at the combination of the A and P, what is the meaning of this? The database can have, there are the different database are specified here. Sky, Dynamo, Cost database, uh, RIAK, okay, RIAK. These all are the different database are available there. Okay. Coming to the second combination, consistency and partition. So C commit atomic, okay. C commit the atomic across the entire distributed system. Okay. So and P is similarly a system respond incorrectly when there is a total network failure. Okay. So the combination of C and P have the example database like from here, big table, HBase, uh, Scalaries, Redis, Berkeley DB, Mema, and MongoDB, TerraStore. Okay, so these all are the database basically. So at last, the combination we have C and A. Yes. Okay. Okay, let's start the last combination C and A. Here, the data model, like from here you can see that RDBMS, MySQL, okay, and Aster data, Greenplum, and Vertiga. So these uh, and the topic of the CAP theorem. Okay, so next we have in the slide. Now I'm going to explain that is basically about the CAP theorem. What it is basically means ultimately there are the three parameter will be checked: availability, what is the meaning of the availability, partition tolerance, and consistency. Okay, so in the next slide, now I'm going to explain about the Hadoop ecosystem. That is very important to go to understand a big data environment basically, or to become a big data analytical, you have to know the what are the different component Hadoop ecosystem have basically. So what is Hadoop ecosystem? From here you can see that Hadoop ecosystem is a platform or a framework which have in the solving the big data problems. Okay, so it comprises the different component and services like ingesting, storing, analyzing, and maintaining. Basically, okay. So most of the services available in Hadoop ecosystem are to supplement main four component of the Hadoop, which include from here from this diagram you can easily understand that there are the main four component Hadoop ecosystem is contained. HDFS, okay, from here you can see that HDFS and Yarn, MapReduce, okay, and common some common available Hadoop ecosystem environment basically. Okay, so Hadoop ecosystem include both Apache open system projects and other wide variety of commercial tool solutions basically. Okay, and some of the well-known examples are like OZ, Pig, Spark. Okay, so let me start with the storage first. Uh, Storage HDFS. So what is HDFS? I'm going to explain HDFS in detail in the next slide or as well in the next session. Okay. Okay. So the Hadoop file system is a storage system. Okay. Which runs on a Java programming language and used as a primary storage device in Hadoop applications basically. Okay. And HDFS uh, consist of two components which are name just a minute. participants are waiting. Okay. SDFS basically, uh, let's start. Okay, so the Hadoop file system is a storage system which run. I have already told that run on Java programming language. Okay, and SDFS consists of the two components which are uh, name made and data made. Okay, these applications are used to store large data across multiple nodes on Hadoop cluster. Okay, second is yarn. It is mostly yet another resource negotiator. You can say. What is the full form of yarn? Anybody have idea? YARN, yarn. So anybody have idea? You just have to type in the chat box. What is yarn? Yes. Anybody have idea about yarn? YARN, yarn. Okay, it is mostly it is called yet another resource negotiator. Okay, and which act as a like a brain of a Hadoop ecosystem, and it take responsibility in providing the computational resources. Uh, basically, yarn. Anybody? No, nobody is written on the chat box. What is basically the yarn? And basically the responsible to manage the resources and need for these resources are needed for application execution. Okay, and yarn consists of uh, two essential component. They are resource manager. Okay, and uh, basically it is uh, mode manager also, resource manager as well as mode manager, which in which mode means write mode or in the read mode basically. Okay, and third one we have let me have map reduce. Okay, so map reduce act as a core component in Hadoop ecosystem, as it facilitates the logic of processing to make it simple. Okay, so MapReduce is a software framework which enable us in writing application across the large uh, sets of using distributed and parallel algorithms. Okay, so in Hadoop environment, parallel processing features of MapReduce, there is a crucial role in Hadoop ecosystem is that it have in performing big data algorithm system using multiple machines in synchronize with the cluster. Okay, uh, then come to the Apache part. Apache is an from here you can see that Apache is what basically the Apache. Okay, Apache part is an essential product from the Apache Software Foundation that you know very well. Apache have Apache Software Foundation that include various types of tools also. Okay, and it considered as a powerful data processing engine. Spark. Okay, let's start with the Spark. Spark is empowering in big data application around the world. Okay, and it all started within increasing means of enterprises where is MapReduce enable and handling them. Okay, so the growth of the large unstructured amount of data uh, increase need for speed and fulfill the real time analysis and led to invention of the Apache. Okay, next we have uh, Hive. Okay, anybody have idea about Hive? Apache Hive, that is also called Apache Hive. Okay, so Apache Hive is a data warehouse basically. Okay, open source data warehouse software built on Apache Hadoop for performing data query analysis. Okay, and Hive mainly does three functions. Okay, data summarization, query, and analysis. Okay, so it just like work as an SQL. Okay, so Hive using a language called HQL. Okay, Hive query language, not structured query language. Hive query language. Okay, that we call HQL. Okay, which is similar to SQL, and Hive query language work as a translator basically, just like in SQL also work as a translator. Okay, so Hive query language also work as a translator, which translate the SQL query into MapReduce job, which will be executed on uh, uh, Hadoop ecosystem basically. Okay, next we have HBase. HBase. Okay, so HBase is that we have discussed just like work as an SQL. Okay, it is called HQL. Okay, so HBase is considered as a Hadoop database because it is scalable, distributed, and because of no SQL. Okay, so database that runs on top of the Hadoop. Okay, that is from here you can easily see that this one is the database that run on the top of the Hadoop. Okay, and Apache HBase is designed to store the data on uh, just like in the table format. Okay, so which have billions of rows and billions of columns. Okay, so HBase give access to that the real-time data to read and write SDFs. Okay, then come Apache Pig. That's right. It's specified. It is in one of the scripting language. Okay, so Apache Pig is a high-level language platform for analyzing and querying the. Okay, so Apache Pig from here. So Apache Pig is a high-level language that platform for analyzing and querying large data set that are stored in SDFS. Okay, Pig work as an alternative language through Java programming language for MapReduce and generate MapReduce functions automatically. Okay, and Pig included Pig scripting language. Okay, LAT basically. Okay, so translate Pig script in MapReduce, which can run on a yarn. Okay, and process the data and in the SDFS cluster. Okay, so Pig is best suitable. Apache Pig is best suitable for solving that required multiple data operations. Okay, and it is more like processing a language than a query language basically. Okay, so Pig is Apache Pig is considered as a highly customized because user have choice by using preferred scripting language. Okay, then come on OZ. It is a tool in which OZ. It is a scheduling tool basically, in which all sort of program can be uh, pipelined in required manner to work in SDFS. Okay, the Uzi work as a scheduler system to run and manage Hadoop job. Okay, and at last to I just go to introduce Zookeeper and Ambari. Okay, and Zookeeper basically in a open source project designed to coordinate multiple services in Hadoop ecosystem, and it uses a simple API and architecture. Ambari, again, it's also one of the open source software of the Apache software foundation, and it makes Hadoop manageable, basically. Okay, so it consists of software which is capable of managing and monitoring of Apache Hadoop cluster. Okay, so that these all are the components of the Hadoop ecosystem, and as a big data data database environment design, we have to know all in detail all the components basically. Okay, we know to all the components in detail, and we know all the role of all the components of Hadoop ecosystem basically. Okay, so in that particular lecture, we have discussed HDFS, yarn, and various component of Hadoop ecosystem like Ambari, Zookeeper, HBase, Pig, Hadoop, Apache Pig, okay, Spark, Hive, okay, MapReduce, and what are the different roles in Hadoop to make a Hadoop ecosystem basically, okay, and to solve big data problems, okay. So that is all about the Hadoop ecosystem. So we have discussed today CAP theorem, Hadoop ecosystem, or and different component of a Hadoop ecosystem. And in class we have big data and technologies landscape. Okay, that we have discussed because in NoSQL means here we have database like MongoDB, CouchDB, Cassandra, Redis, Bigtable, etc. Okay, and in the MapReduce, we have different technologies landscape like Hadoop, Hive, Big, Cascading, okay, Plume, okay, lots of available technology landscapes are available with the MapReduce. Okay, and in storage we have S3, Hadoop distributed file system. Okay, in server we have EC2, Google App Engine, Elastic, Beanstalk, Heroku, okay. And in the processing, simply we have R, Yao pipes, mechanical, Turk, okay, and big sheets, data meat. These all are the basically the big data technology landscape. Okay. Uh, so today is all over about that particular class. So thank you, all of you.